Sort of fun. So here I'm looking at the inequality 2x plus 3y is less than or equal to 12. Okay? Well, how am I going to deal with this? Well, the first thing I might want to do is find the graph of this to compute the boundary line. So I'm going to look for the boundary line. That's a little teeny bit of work. So how can we do it? Well, one way to do it is just to write this as y equals mx plus b. So let's consider the boundary line equation. And solve it for y. So I'm going to subtract 2x from both sides. And I see 3y equals negative 2x plus 12. And now I'm going to divide both sides by 3 to undo the multiplication of 3. And when I do that, I'm actually going to divide this piece by 3 and this piece by 3. And so I see y equals negative 2/3 x plus 4. Okay, great. Well, now I can actually graph that boundary line. Has a y-intercept of 4 and a slope of negative 2 over 3. That's rise over run. So I drop down 2 and go over 3. 1, 2. So I drop down 2, 1, 2, and go over 3. 1, 2, 3. Drop down 2, go over 3. 1, 2, 3. Okay, and now I'm going to connect them. Now, what kind of line should I put in here? Should I put in a dashed line or a solid line? Well, I go back to the original inequality and notice that I have something is less than or equal to something else. That means that I'm allowed to have equality, and the equality, of course, lies right on that line. So, in fact, what I see here is that I am using a solid line, solid gold, just to put that in there, because I see that there's equality allowed. That makes it solid. If there's no thing there, then I use a dash line. Now, which side do I have my solutions on? I'll pick 0, 0 again. So plug in 0 for x and 0 for y. And so is that a true inequality? Is 0 less than or equal to 12? It sure is. And so I see I shade down. If it weren't, I'd shade the opposite side. And so what does that mean? It means that any point in this orange region, any point at all that you pick, x, y, that are in that orange region, they will be solutions to this inequality. Lots of solutions. In fact, a half plane worth of solutions to this linear inequality. Pretty cool.